Hello everyone, I am Shashank. In this experiment, we will analyze the different sound signals: train, fan, and speech. All the three signals are in wave format. So, first, the train signal is 1 hour train signal is read by using audio read function in MATLAB. We will take samples for first 30 minutes. Each each second is taken as one block, so total 30 into 60, 1800 blocks are present in a 30-minute sample. And Fs is sample frequency. Sample frequency is one number of samples in 1 second. So total number of samples in 30 minutes data is 1800 into sample frequency. Then we will read the first 30 minutes data of a train signal using audio read function. Then we will create some null matrices to save data from train signal, and we will create a audio normalization function. We have to write a separate code for audio normalization. In MATLAB, this is the code for audio normalization function, and I took maximum amplitude to be 1 and found the variance, skewness, and curtices of train signal, and finding the threshold values. For finding the accuracy, we will use max and min of train variance and curtices and skewness values. Then we will store this all data in an Excel sheet with the train by using write table function, and we will do the same with the fan signal. We will create a null matrices to store data, and we have created audio normalization function. We will use the same function, and first 30 minutes of the data is read again in the fan signal also, and we will find the threshold values for fan signal, and we will store all these values in a Excel sheet, and we will do the same with all the speech signal also, and finally all these tables are stored in a Excel sheet, and we will go to the analysis part. Here train variances, we have to find the accuracy of the values we have plotted. So by using the next 30 minutes of the data, we will find the accuracy, and by using audio normalization function, we can find the next 30 minutes of the data, and we will add 1 to each if the value is in between the threshold values, and if it is between the maximum and minimum, we will add the function. If it is not, we will not add, and we will do the function in the MATLAB function fan.mat mp3 function, and we will take samples from the next 30 minutes. So we have to do samples from 1800 Fs to 3600 sample frequency. Then we will do the same with the fan accuracy. The diagonal values will give the accurate values, and the remaining values are not correct values. So, and by using the same, we will do for speech values, and train. If the value is lying between the threshold values of the minimum and maximum of the speech, we will add the values. So finally we will divide the values with the total sample frequency. If it is nearer to 1, our accuracy is good, and finally we'll do this. And coming to the design part, here I used a radio button group for confusion matrix, train, fan and sound, and button group for variance, curtices and skewness, and push button for to load a matrix. Now to run the code, it may take some 2 minutes. We will wait it. It takes some time to run the code. So finally we will get a confusion matrix when we select variance, curtices and skewness. It's